1. Alright, so the topic is differential equation. And this is how I would start. I would start out by saying to you that any relationship between the variables x, y, and any or all of the derivatives dy by dx, d2y by dx squared, d3y by dx cubed is called an ordinary differential equation. Now, the order of a differential equation is the highest derivative in the differential equation. So this is important. The order of a differential equation is the highest derivative in the differential equation. So if the highest derivative is d2y by dx squared, then it's second order differential equation. So the degree of the differential equation is the power to which the derivative of the highest order is raised. So if you have what? d2y by dx squared all square, then that becomes second degree differential equation. All right, don't stress it. All right, so moving on. Now, dy by dx plus y is equal to x is first order linear. It's a first order linear differential equation. Now, first order because the highest derivative is 1, and the degree is what? 1, because the dy by dx is raised to the power of what? 1. So it's first order linear. d2y by dx squared plus dy by dx plus y is equal to x. That is second order linear. Still linear because the d2y by dx squared is still raised only to a power of 1. All right, we need to look at solving a first order linear differential equation. Now, if you have a linear equation, please look at this. Dy by dx, if you have dy by dx plus py is equal to q, where p and q are functions of x alone or are constant. So first of all, for your differential equation to be first order linear differential equation, it must be of the form dy by dx plus py is equal to q, where p and q are functions of x alone or are constants. So p and q, they must be functions of x, or they should be what? Constants, in order for this differential equation to be first order linear. In order for it to be first order linear. All right, so this is important. It's a principle. So I'm saying it's a principle. Let us see what happens if we differentiate y e to the integral of e to the integral of p with respect to x. Now, first of all, it's a product differentiation, don't it? So if I differentiate, product differentiation says what? Leave the first, differentiate the second. So it is what? Y, leave the first, differentiate the second. This says what? If you differentiate, all right, if you differentiate e to the x, what do you get? But you have to also multiply by the differential of the what? Inside function. All right, so if I differentiate e to the x, e to the integral of p dx, I'm going to get e to the integral of p dx multiplied by the differential of the inside function. The inside function would be what? The integral of what? P dx. Now, what would be the differential of the integral of p dx? What would be the differential of the integral of what? P dx? It would be p, actually. Go think about it for a second. if you integrate p dx, let us say, oh God, no man, p is not a constant. P could be a function of x as well. But look at this way. You're differentiating the integral of p. Remember, differentiation is the opposite of integration. So if you integrate p and then differentiate it, you get back what? P. Talk to me now. If you integrate p and then what? Differentiate it. Remember now, we are multiplying by the what? The differential of the integral of p. If you integrate p and then differentiate it, you'll get back what? P. So the differential of the inside function is p. Now, so that is what? Leave the first, differentiate the second, plus, now, differentiate the first, so that will be what? Dy by dx. Leave the second, e to the what? Integral of what? P dx. Alright? Good. Now, there's this one little thing. Let's factor out e to the integral of p dx. If I do that, I'm going to end up with what? E to the integral of p dx. And inside the bracket, I'm going to have what? Y, or py. It's py. It's what? Py. Alright. Someone I just don't think so. This is looking the way I want it to look. Ah, it does. Dy by dx. Alright, very good. Alright, so this knowledge is important. The knowledge that if I differentiate y, e to the integral of what? P dx. If I differentiate it, I'm going to get what? The integral of what? E to the integral of p dx, and inside the bracket I have what? Dy by dx plus what? Py. Alright? Because if you differentiate y, you get what? Dy by dx. You good? The what? Here? Sorry, here? Here? No, that is just saying, that is just simply saying you must differentiate what? Y, e to the integral of what? P dx. That's all it's saying. And now, what is the connection? What is the connection? You see, if you look here, you can probably see some form of connection. Alright, what is in the bracket? Inside the bracket is the same thing as that, don't it? The left hand side, which is what? Dy by dx plus what? Py. So that is the connection between the two. Alright, let's turn the page. Alright, so, alright, I think what I did at the bottom I was supposed to do at the top here. It's fine. So let's just scroll up. Alright, solving a first order linear differential equation. So let's apply the principle. Now, what I'm going to do is I'm going to what? Multiply both sides of the equation by the integral of p dx. I'm just trying for you to understand it. Dy by dx plus py, and that is equal to e, the integral of what? P dx times q, don't it? All I did was multiply both sides by the integral. And the reason for that is that I can see now that my left hand side is the differential. The left hand side is actually what? The differential with respect to x of what? Y e to the integral of p dx. Do you agree? Talk to me now. Because when I differentiated it, we saw in the previous page is that I get, don't it? And that is equal to now what? E to the what? The integral of px q. Now, the next thing now I need is that. So if I integrate both sides, I'm going to get what? Y e the integral of what? P dx is equal to the integral of q e to the integral of p dx. Alright, with respect to x. In a sense, this is how you solve. Alright, I guess you're going to see it in action, but essentially this is how you solve what attendant. This is how you solve a first order linear differential equation. Alright, let's have a look at example 1. Alright. In example 1, it says solve the differential equation dy by dx is equal to y, dy by dx plus y is equal to x. Alright, first of all, can we see that this is first order what? Linear. The first order linear form, what is this? dy by dx plus py is equal to q. Can we see that this is that format? And if that be the case, would you agree that p is equal to 1 and q is equal to x? Do you agree? Help me, man. Remember now, p and q could either be what? Constants, or they could be what? Functions of x alone. Functions of x alone. Now, but we already saw that if I multiply both sides by e, the integral of what? P dx. Alright, so let's do that. So, and then integrate both sides, I'm going to get what? Y e to the integral of P dx would be equal to the integral of what? The integral of what? Q e the integral of P dx, and I'm integrating this with respect to x. That's my solution. So let's put it in. So this becomes what? Y e the integral of what? P, which is what? 1 dx is equal to the integral of x e the integral of what? 1 dx by x. We're good so far? Now, when I integrate 1 with respect to x, I'm going to get what? X, don't it? So let us say I'm going to have what? Y e to the what? X is equal to what? The integral of x e to the what? X dx, don't it? Fine. I'm going to have to integrate this by what? By parts, don't it? Fine. I'm going to call what? Which one I'm going to, if you integrate by parts, it's going to be what? The integral of what? U dv by dx with respect to x is equal to what? uv minus the integral of v du by dx, don't it? Fine. So something has to be u and something has to be v. So I'm going to let u be equal to x, because that's easy to differentiate. So du by dx would be equal to 1. Then I'm going to let dv by dx be equal to e to the x. Talk to me now. Now if I integrate e to the x, I'm going to get back what? E to the x. So v would be equal to e to the x. Alright, let's carry this knowledge to the next page. Look on space, go. Alright, so let us start by saying that we have y e to the x is equal to, remember it was equal to the integral of what? X e to the x, which we work out to be u which is what? X, v which is e to the x minus the integral of what? V which is e to the x, du by dx which is what? 1, and then so no bother put 1 because 1 times e to the x is still e to the x. So this is going to be equal to x e to the x minus e to the x plus c. Do you agree? So this is y e to the x is equal to all of that. Let's divide this entire equation by e to the x. We're going to end up with what? Y is equal to x minus 1 plus c over e to the x. Do you agree? This would be y is equal to x plus 1. Sorry, is it plus or minus 1? Minus 1? Minus 1 plus c e to the minus x. Essentially, that is the solution of a differential equation. So when you're solving a differential equation, essentially what you need to get is that you need to get somewhat. Remember, you differentiate a polynomial or you differentiate an equation, and you get this what? Differential equation, don't it? So if you integrate, you understand, when you solve the differential equation, you should get back your what? Initial equation. Alright, so our initial equation is y is equal to something. Alright, let us maybe have a look at a different one. Come, young lady, wake up. Rise up. Alright, let's look at this one. First of all, we have to be able to look at this, at least to see that it is what? Linear. It is first order linear. We can see that. It's first order linear. Now, the issue is we have x dy by dx plus y, and this is equal to x cubed. Now, my problem is that it's supposed to be in this form. If it is in this form, dy by dx plus py is equal to q. If it is in that form, I know exactly what to do. So let me get it in that form. For me to get it in that form, there cannot be any x here, don't it? I don't need no x there. So, therefore, let's divide the entire equation by x. If we do that, I'm going to get what? Dy by dx plus 1 over xy, do you agree, is equal to x squared. Do you agree? Help me, man. I divided the entire equation by x. So now it is in the form that I want it to be in. Alright? Now my p is equal to what? 1 over x, and q is equal to x squared. Do you agree? Now y, the integral of what? P dx is equal to the integral of q the integral of p dx, don't it? That is the solution. That is the formula for the solution. So it means that y the integral of what? 1 over x, that's p dx, is equal to q, the integral of q, which is what? X squared. Do you agree? And then the integral of 1 over x dx. All right. When I integrate 1 over x, I'm going to get e to the x, don't it? I'm going to get ln x. So this is y e to the ln x is equal to the integral of x squared e to the ln x dx. What does e to the ln x equal to? E to the ln x. What we want to find out is what is e to the ln x equal to, don't it? Let us say it is equal to a, don't it? Let's take log to the base e of both sides. So I'm going to have what? The power is going to come to the front, so that is ln x, don't it? And then what? ln e, don't it? And that is equal to ln a. I took log to the base n of both sides, don't it? But ln e is equal to 1. Log to the base e of e is 1. So what I have is ln x is equal to ln a. If ln x is equal to ln a must be equal to what? X. But a is e to the ln x, don't it? So e to the ln x must be equal to x. Very good. Alright, so now we know what that is equal to. We're going to have, are you guys looking? We're going to have what? This would be y x. Do you agree? Because e to the ln x is what? X is equal to the integral of what? X squared times x dx. So yx would be equal to the integral of x cubed dx. Do you agree? So yx would be equal to x to the fourth power, because when you integrate, you increase the power by 1 and then divide by the new power, which is 4, plus c, which is the constant of integration. What I want you to know is I'm going to divide the entire equation by x, don't it? So I'm going to get y is equal to x to the 3 over 4, do you agree? Plus c over x, don't it? So my answer would be y is equal to 1/4 x cubed plus c x to the minus 1. Alright? With that in mind, guys, I want you to try this differential equation.